So this is oral. I'm going to do number 7 right now. And this is going to help us as we go further anyways, Jess. All right. Does 0, 2 fall on, above, or below the line that is y equals 2x plus 1? Okay. So I'm going to make a nice little generic line graph. My y-intercept is 1, which means over 0, up 1. And my slope is 2, which is 2, 1, right? So up 2 over 1 looks something like that. It's a solid line because it's equal to. And they want to know, does 0, 2 fall on the line? Above it or below it? Over 0, up 2 is above the line. All right? Now there's a reason why they're making you practice this, and we'll get to that here more in a little bit. How about I do another one just like that? Number 9. Okay? Number 9, they have point -1, 2. And they want to know if it falls on, above, or below. So the equation is y equals -1/2 x plus 2. So my y-intercept is 2, 1, 2. And my slope is -1/2. Down 1, right 2. And you know, when I sketch them this way, they're not extremely accurate because obviously my lines are not, there's not grids, but you could tell that -1, 2 is right about there, even with my poor graphing here as I'm doing it. So this point falls below the line that I just graphed. Okay? So far so good? Okay. Number 11. Number 11. 4, 5, and they say y equals 1/2 x plus 3. All right? So my y-intercept is 3. 1, 2, 3. My slope is 1/2. Up 1 over 2. Okay. There's my solid line. And if you were using graph paper, it would look a lot prettier. Where does 4 fall? Or where does the point fall? 1, 2, 3, 4. 1, 2, 3, 4, 5. Looks to me like it falls on the line. And I bet you if you used real graph paper, it would probably line up just fine. Okay? So that's the benefits of using that nice paper. We're going to do 13 and 15, and then I'm going to do a couple more examples for the lesson, okay? 13. 13 says, give an example of what that is telling us. Is it x plus 1 is greater than or equal to 0? Y is greater than or equal to 1? X minus 1, blah, blah. Or x is greater than 1. Okay, so, yes, sir?
When it's equal to, it's dotted, right?
No, when it's and equal to, it's solid. So, he just brought something up. We already know the line is solid, so that means only A, B, or C can possibly work. Okay? Because solid lines are equals, less than or equal to, greater than or equal to. Okay? And you guys missed this the other day. But dotted lines are only if it's greater than, less than, or greater than. Okay? So I already know, based on how they graphed this line, which looks like it's at 1, that it's equal to of some sort. And they graph it bigger than and equal to looks like 1, right? So I am going to say that this line is x is greater than or equal to 1. Is that any of the options? Which one? C. Yes. Option C is that option because C says x minus 1 is greater than or equal to 0, which is translated looks like that. Good job. Very good. Okay, be careful. They're going to try and trick you up like that, and you caught them. 15. Last one on this group. I've got an x and a y axis, and it looks like my y-intercept is 0. I'm going to grab my ruler. So I'm going to draw it. Is it a dotted line? That means it's going to be only less than or only greater than. And it looks like it's shaded this side of whatever it is. Okay? So that automatically throws out which one? C. Awesome. Okay. Now, the line itself is downhill. Downhill means it has a negative slope. You may not remember that. Are there any here? Well, there's only one, isn't there? Are there any here that have a negative slope? A. And A is correct. That's the only one with a negative slope. If you moved B and made it negative y is greater than negative x, you would divide by negative y and it would be y is less than x. So that one wouldn't work because it would be a positive slope. C is greater than or equal to, and y is greater than x, that's a positive slope. Okay? So look for little hints like that. Downhill means it's negative slope. So that means y equals negative mx plus b is what you're looking for. Okay? It does not have a y-intercept of anything other than 0. So I know I need y equals negative mx plus 0. Okay? And that's how I figured out what would best fit. Okay? Now for the lesson that we're doing, we're graphing systems. And in order to graph systems, you're going to need 2 different colors of pencil or pen. All right? That's going to be the easiest way to do it. And I'm going to show you how this works. If I ask you to graph one thing, you can use just one pencil or one color. And I'm going to graph this first example, which is 3x minus 2y is less than or equal to 8. This is not in your book. Okay, this is in my book. So I would start this off by converting it to y equals mx plus b. Okay, so I've got negative 2y, negative 3x plus 8. Divide by a negative 2, and I now have y is greater than or equal to positive 3 halves minus 4. Does everybody see how I did that? I'm not going to show all the paper just to save myself steps. Okay? All right, so now I'm going to graph that line. Y-intercept is negative 4. So I'm going to focus on the lower quadrants. 1, 2, 3, 4. And my slope is 3, 2. Up 3 over 2. Okay? Less than or equal to means it's a solid line. And I do have graph paper for you, so don't worry about it. But here's the rub. It says less than or equal to, which means I got to shade something. Either this side is satisfying the equation or that side is satisfying the equation. So I am going to test the easiest possible set of coordinates, which is 0, 0. Okay? So 0 greater than or equal to, that should be an x there, 3/2 times 0, which is 0 minus 4. 0 is greater than or equal to -4. True or false? 0 is greater than or equal to -4 is true. Which means if that is true, then this entire side is true. Okay? So you would shade everything that includes the points that you tested. Okay? All right. That's graphing a single linear equation. What if you're given two of them, like this, 2x plus y and x minus y. Okay, so now it says graph this system. Okay, graph this system. Turn these into y equals mx plus b. This one's easy. Y is greater than -2x plus 1. And I am going to use a black pen to graph that one. This one, -y is less than or equal to -x plus 3. When you have a -1y, think of that as the coefficient that you would divide. Divide by -1, -1, -1, and that flips everything. Y is greater than or equal to, a negative by a negative is a positive x, positive by a negative, okay? And I am going to graph that equation using red, all right? Starting with the black one. 1 is my y-intercept. My slope is -2, which is down 2 over 1. I'm making it a little bigger for myself. So this is my black line. It's greater than, so will it be dotted or solid? Try again. Yep. Okay. Arrows, arrows. Let's test 0, 0, which is right here. 0 is greater than -2 times 0, which is 0 plus 1. 0 is greater than 1? Nope. That means the other side gets graphed, or shaded, I should say. Okay. The red one. Y is greater than or equal to x minus 3, and that means my slope is a 1. -3, 1, 2, 3, and my slope is 1, which means up 1 over 1. It is a solid line because it's and equal to. On your graph paper, it's going to look prettier, but. Now, pretend like the black graph has disappeared. We are trying to figure out what is true for the red graph. Is it going to be here or is it going to be here? Let's use 0, 0 again. Nice and easy to test it. 0 is greater than or equal to 1 times 0, which is 0, minus 3. Is 0 larger than -3?
Yes.
That means that everything, including those points, is true. Okay? Where the two colors cross one another is where both equations are satisfied. Okay? Everything on and to the left of this line up to and stopping at that dotted line. I'm just highlighting it for you so you can kind of see that the red line and the black line cross at that point.
Tracy did something, you were 15 minutes back.
Yeah, it's okay. I can go a little bit over.